Continuing with the teardown of parts for the Cutlass, need to take the dry sump pump apart. I mean, just any engine failure, this is a good idea just to absolutely make sure that you got it cleaned out and that there ain't debris or anything still in the pump, that as soon as you go to start up on a brand new engine, that anything is going to suddenly be pumped back in and ruin the new engine. This, for sure, I knew I needed to come apart because it had a tight spot in it, and it makes a lot of sense because there is some bearing material folded over into these pump rotors. You can see there's some material smashed in on that one, as well as this one. What's pretty amazing is the pump survived. However, these are beefy parts in the grand scheme of things. It certainly got beat up a little bit. You can see some material transfer where it kind of smashed some stuff in there, but I mean, really, I should be able to just sand and buff these parts and they'll be good to go. I mean, there's a lot of material jammed into this one, but if I dig all that out, I mean, it looks like it was all probably the softer Babbitt material that it did eat. And even though that there's a little bit of dings and dents, oh look, there's a big old pump in that one. Look, there's a big old dimple smashed into that one. But it did make plenty of oil pressure still, even after the fact. So they're definitely not in perfect condition anymore, but as long as I take my time and clean it out, this is obviously still a functional pump. It will be a good pump again. Got everything cleaned up now. Surprisingly, I mean, there's just, a little bit of damage here and there, but overall not bad. I mean, these got a little banged up in different places. I can see that something got smashed into it on the backside there, but cleaned out the bearing material and should be ready to put it back together. Just got some new seals, just for good measure. As long as it's apart, it'd suck to put this thing back together, get everything running again, and then have a leak somewhere. Alright, dry sump pump is back together. Turns nice and smooth, which, expected it to. But this has been on the car for a couple of years now because I had a Canton 3-quart AccuSump, which I still have, even with the dry sump, because it acts like a pressure spring to even out the peaks and valleys of the dry sump, because the dry sump will, peak and valley quickly with engine RPM. So it just balances out the oil flow and pressure for that. But anyway, with that AccuSump and a 6-quart, fully baffled, trap-doored oil pan, I was still losing oil pressure in the corners. So we're going from 6 quarts to 9 quarts in the engine and still losing oil pressure. So it was time to go to a dry sump just to take care of that. Now, if you don't know what a dry sump does, what it is we're storing oil in the tank instead of the oil pan. And the way this works is we pull oil from the tank, comes into the pressure unit down here. It's the very last stage. It's adjustable, so we're pulling oil in, pushing it out. This is just what supplies the engine, so we're feeding that into the block where we normally would have the oil filter mounted up. Instead, we got the oil filter inline remote mounted before it gets to the pump. Then it goes to the engine. After it goes through the engine, now it's all over the place in the engine. It's up in the heads, the valley, the oil pan, all of it. So what we're doing is we're using these other 3 stages to pull it out of the engine. So I've got 2 that hook into the oil pan, so any oil that gets down to the bottom is being pulled out immediately. So that's where the dry sump comes in, is there's not actually any oil staying in the oil pan, because having the 3 stages or just, you know, any stage amount there that's usually more than a single pump, is pulling a vacuum inside of the crankcase. And what that vacuum is doing is, it's as soon as the oil comes off of like the crankshaft or out of the lifter bore or wherever the heck it's coming out of the engine at doing its lubrication job, it immediately gets sucked to one of these, and they pull 2 from the pan, puts it back in the tank. The smaller one here is actually pulling from the valley in the block. I modified the block so that I could feed a line in, and then made a special hard line inside of the valley. And I have a lot of the other areas plugged up there to reduce windage dropping down on top of the rotating assembly. Now that I'm thinking about this, if I hadn't done that, maybe it would have been enough splash oil to keep the cam alive for a little longer. Yeah, but point is, we need this, and that one's pulling from that area in the valley, and that's catching all the drain back from the cylinder heads. I'm not getting a ton of oil up in the cylinder heads because I have restrictors, because I'm running a solid roller lifter and roller rocker, so I don't need a ton of oil up there. So I have a 40 thousandths restrictor in every single lifter bore, which limits the oil going up the push rod to the top end. And it's more than adequate. So the smaller one is what's pulling back from there as well. And also putting back into the tank, and then the cycle starts all over again. But what this allows is that we don't lose oil pressure in the corners, because all of the oil that isn't in circulation is in the tank, so our pressure side of the pump is constantly fed with good solid oil, because the way it goes into the tank, it kind of circulates and airs out the oil. So if there's any bubbles or extra stuff, because these pumps, these scavenge areas are sucking a lot of air along with the oil. That's what's making the vacuum. Once they go into the pump, it kind of throws it out the side, so that separates the air and the water, and then the feed for the pressure side is coming right off the bottom of the tank, so it's always getting solid oil, non-aerated oil flow as pressure fed to the engine. Moving over to the steering here, got everything unhooked, and looks like there's this outer layer that's loose, the inner one's loose. Really, we're only worried about that inner one, which this is actually this is an upgraded factory bearing. I think this one's out of like a Jeep, but it pops right in, and then it's just this little sheet metal clip that's supposed to retain it, kind of a thing, and that just doesn't fit well. Fits good on the inner shaft there, but it just, this plastic piece into this is not a good solution. So we're going to be changing that out for a firewall style mount. I had to order one because it's a different size than what I got for the tube frame going on. Here it is. So this thing, it's just this one's a 3/4 pass through. We'll get one that's a 1-inch pass through, which is the size of that inner steering shaft, and then I'll make a bracket for the firewall so that it can bolt on. Then that should take care of all of the slop on that end of the steering column anyway for the foreseeable future. But I think I might just pull the whole steering column out. There's probably, I don't know, some stuff I can take off of there, like the column shift related stuff that we're not using anymore. Like, I don't know, might be a pound or two to take of just crap off of it, but is it worth it? But just something to do in the meantime, I guess. I forgot how much stuff was under the dash. Oh, it's a mess. At least everything works down here, but oh look, you can still see my butt connector throttle cable repair at the track like 4 years ago. 3 years ago at least. Yeah, I'm really tempted to try to start stripping wires out, but I don't want to get into that today. That's more than we need to be worried about. So we're just going to ignore that. On the column though, I know the neutral safety switch isn't hooked up at all, so we can eliminate that. Because it has to do with here. This one's probably our reverse lights. I don't know. Well, that one has the connection. So that'd be neutral safety, reverse. Don't know what this one's gonna be because it's got a link bar down here that hooks in with the column shift. So, not sure about that. Here, oh, wait. Nope, that's my high beam switch. Alright, well, we gotta keep that one then. But otherwise, looking at this inner second sleeve here, where it's cut off, that was the arm for doing the shifting. So I'm wondering if I can disassemble this column enough to take that entire tube out of the center. Because there's probably a couple of pounds there. I don't know, this steering column is awfully heavy. So I bet quite a bit of it's that linkage in there. And then really there's probably some stuff up here we can get rid of too. I just not sure what, but we'll see how it comes out. Alright, I've made it this far. I know I didn't show you, and I'm not going to because I had to look up how to do this with, luckily, there if you search G-body steering column disassembly, there's a old forum post with pictures, so that works really nicely. And I'm not about to try to go through this and explain it to somebody because I had to do a little bit of destruction to get it apart, and quite frankly, if somebody asks me a question about it later, I'm not going to remember what the heck I did to take this apart. So search it on the online. If you're planning on doing this, go from there. But anyway, I just wanted to point out that once I got to this point in that post with pictures, it talks about taking it apart this far to fix the tilt being loose. And I know for a fact that mine is, and the reason being is not a single one of these bolts is tight. Like, I didn't even need the ratchet to start unscrewing them because they're all loose anyway. So apparently that is what ends up leaving a bunch of slop in the tilt. So I guess I'm a little more happy about the fact that I chose to take this apart now because there's clearly some stuff that need maintenance in here anyway. And here, finished getting that inner tube out. Lots of dirt in there. But anyway, I guess disappointingly, this doesn't weigh very much. However, it does appear that I should be able to just cut it right here and then be able to reassemble everything. I think the only thing that might be a little bit, well, no, because everything will hold this from twisting and flopping around. Anyway, we're just eliminating this whole section of tube. Now with the firewall mount bearing thing that I got, it's I don't know, it ain't quite a perfect fit on there, so that's a little disappointing. Might want to be doing something a little bit different. So, flip side of what I can do now that all this stuff is going to be out of the way is I could, I need to clean the dirt out of this thing. I could make my own bushing for this end so that I can fit it to that inner shaft. I probably have some Delrin laying around that I could make it out of, and that I wouldn't worry about wearing out at all. I could probably also finish cutting this tube off at the step side. I say finish cutting off, I haven't cut it off yet, but I can cut that little bit off, and then that way at least we've got a flat part to push in there, and I can machine a piece to press in there. Or I'm sure we could even find a actual bearing that might go in there. Yeah, this is what a 2-inch OD, so it'd be like an inch and 7/8 ID, possibly. However, with you know, this should be like 1 inch and 3/3 or something like that, and it's loose on there. So I think that shaft's actually under 1 inch instead of right at 1 inch. That's why it's got some extra play. So I think that'll be my plan here. So after cutting this off, it didn't come out all that straight, and I didn't quite have enough material, size and diameter, in order to make that out of Delrin. So I thought about just making a washer fit and welding that in there, and then making some kind of step to hold the Delrin. But I also had some body spacers left over, you know, just from the radiator core support ones that I didn't use out of the solids. So I just took a piece of that, got the OD cut down, so it'll be a little bit of press fit on both of those there, and then we've got the Delrin, which slips nicely over the end. It's got just a little bit of play there, but it snugs up as soon as it gets up a little bit higher, so it'll end up sitting right about there. Cut a small groove in there just to be able to smear some grease in. And the plan is I'm just going to pound this in from the front side. If I ever have to do any work to it, pretty much going to have to take apart the whole dang thing again anyway, just to get the shaft out of the way and then pound this thing out. But you know, there might be a possibility of being able to change out the Delrin, but I wouldn't hold my breath about it. But I'm not worried about ever having to change this thing, because the Delrin holds up for suspension bushings there. It'll hold up for this thing for pretty much forever. Well, that went in slightly easier than I hoped. So let's just make sure that it doesn't come out. Ah! No need loose parts though. Alright, just gave it a little dimple down on that piece of steel right there, just to fit in that cup we had on the OD. So if it decides to move at all, it's not going to fall out or travel up the pipe. So should be good with that. Well, it's assembled again. However, I'm thinking the top bearing here must be totally trash, because we still got slop all over the place in there. And that's with this being a super big pain in the butt to get on there. Yeah, well, it's got up and down. Well, it's, I don't know, something's not tight in there. Need to figure that out. Turns out I had this part in upside down, which, you know, it seems like it holds the spring real nice, but actually it's supposed to sit that way in there, because then this open area slips just over to push on the bearing race. Weird. I bet that's been upside down there for a long time. Also explains why I have such trouble trying to get these things assembled. Maybe. I don't know. We'll see. So like 45 minutes of screwing around to figure all that out. And one custom tool later. It's just a washer. Use the same nut for the top. And I just had to measure everything out to know what length I needed and get that cut so that I could just push it down enough to get the threads caught, and then it screwed down enough to get the snap ring in there. And it was super easy, because what the problem is when I was trying to just manually push everything down, it eventually get to the point where the steering shaft itself would drop in, and then it was just hopeless after that. So now real nice and tight. You don't have slop in the tilt. Yeah, we're gonna be 100% better on the steering. I don't know if I showed a before of this, but the hub isn't even tightened down right now, so there's gonna be a little bit of play there, but which is that. Looks like we've got just a little bit of tilt movement yet, but I mean, I'm sure that can't be perfect. There's definitely less of it down in a driving position. So that's good to see. And then, you know, just overall slop in the steering wheel is super minimized. But yeah, again, some of that might go away after I get it tightened up. The reason haven't tightened that up yet, and this is just loose on here, is because I don't know where to index it at until I get everything hooked back up to make sure my steering wheel is straight, because it's kind of pretty big notch as far as the quick release goes, but it's much finer splines as far as where the hub can go. So there's a little bit in between there. The next thing is try to get the side-to-side slop out of the system. I know there's some down here between the rack and the servo. There's a little coupler in between here. It's just a hex style, and it's a bit worn out because, as you can see here, let me tighten the wrench up. Yeah, like that's how much that's moving without affecting the wheel, and that's just slop. And if you think about this, this is probably fairly close to the radius of the steering wheel, so there's that much movement without actually doing anything. So that 6-point coupler, I don't even know if I can replace. The next thing is try to get the side-to-side slop out of the system. I know there's some down here between the rack and the servo. There's a little coupler in between here. It's just a hex style, and it's a bit worn out because, as you can see here, let me tighten the wrench up. Yeah, like that's how much that's moving without affecting the wheel, and that's just slop. And if you think about this, this is probably fairly close to the radius of the steering wheel, so there's that much movement without actually doing anything. So that 6-point coupler, I don't even know if I can replace that, but I'm thinking I can at least weld it to the sloppiest side, and it'll take care of a good majority of that slop. Well, I was mistaken where that play is at, because as a last ditch effort, I actually put a bunch of Loctite inside of that connection. When I put it together last time, this is what it is. So it just engages the hex with the hex, and well, in there you can see there's a little bit of play and wiggle in it. And I ended up just putting it full of red Loctite, and it turns out when I took it apart, that was actually, it was stuck. I had to pry it off. So that actually took care of the slop that was in this. So that can only mean that the rest of our play here is due to this end play in the pinion itself before it switches directions. And oh, looks like I had attempted to do something with that. I got this aluminum shim in there that I was trying to do something with, I guess, and apparently it's just not enough, or I still have yet more play somewhere I don't know about yet. I was able to tighten up a bunch of that slop that was in the rack. I just checked the in-play on the pinion, and it was like 10 thou with the spacer that I had made to put in there before. And I think I didn't really notice a difference when I made that spacer before. However, with it being 10 thou, I ended up modifying a part that went on there just to like tighten that up a little bit, and it seems to have taken care of the in-play. So I don't know what is the natural shimming in there. Or who knows, maybe some parts were missing out of this thing. I got this secondhand. No idea what it's actually supposed to control that. But it seems like we're going in the right direction. Right now, I'm looking at how much Ackerman I have, and I'm trying to decide whether or not I want to stay with the aggressive setup that I have on there, or if I'm willing to cut that modification off so I can fix the boots, since the boots were all just trashed. And you know, honestly, if I want this thing to be more reliable, it should be eliminating possible problems, and I'm sure a whole bunch of, there's always gravel stuck to the grease and stuff. So I just want to show a visualization of what that is. So right now I'm at turned far enough that I'm hitting the sway bar arm on the passenger side of the car. This is the driver's side wheel. And this would be at the original position. So if we want to just kind of take note of where that is on the camera versus, ready? Nope. That being the position I've been running this at. And if we just want to check what that difference looks like, I mean, it's a good 1/4 inch or more as far as what the, you know, the leading edge of the wheel, like trying to go off the center of the tread pattern there, of additional steering. So if that's, should we do some math? 25.5 inch diameter, 25.5 inch diameter tire, and we're gonna, 1 degree is 0.0174 per. So we multiply by 0.0174. So 1 degree difference out at the outside of the tire would be half that though. So divide by 2, say 221 thousandths. So that change we saw was at least a degree, possibly 1.5 degrees. I mean, it's not that accurate with how I'm doing it off the tape measure, but I mean, that's not an insignificant amount of steering angle difference either, versus in the original position on the rack, that would be more close to when the tires are turning. Both are turning a very similar amount. There might even be just a touch of toe in out of that equation there, versus this is definitely creating toe out. And that toe out we're obviously using by making the inside tire turn farther than the outside tire to try to match up the turning radiuses of that slight difference. And that 1.5 degrees, there's a good chance that maybe that's too much. This number is really hard to dial in because there's no right answer, because it changes based on the radius of the corner you're taking every time. Here, looking down at the rack, you can see that it is a drastically big difference between the two, which is why it's so visual out at the tire. But yeah, I'm kind of looking at just, I'm going to be able to chop that ear back off and run it in the original location. I never ran it in that original location. I modified these right off the bat. Well, take that back. I might have ran it for a little while with it in the regular location, but I know I did this pretty early on. And I mean, whether it was quantifiable at the time, who knows? I'd probably not. But it just, what it's happening here is when all the wheel and tire are straight, they're pretty much right in line, versus at the rearward section, it's angled forward. Well, then when you turn the wheel, the inside tire, whichever side it might be, lines up straighter on the tie rod, and that makes more steering angle on that particular tire compared to the other one. And the inverse happens on the opposite side. So the more it steers, the less straight it's getting, and therefore it has less angle. An additional part that has an effect on this is the steering arm. And I don't know if you can quite tell on the camera, but this one is actually flipped from the opposite side. So stock, they kind of angle in, and the position would be right about here. And by moving that pivot point to the outside, we're increasing the Ackerman effect. So really, there's a ton of room to come out here a lot farther if we did like a custom steering arm, but on the bottom, as you can see, it gets really tight to the wheel, and I'm kind of already maxed out on this arm the way it is. And this is a Pinto arm, so it's significantly shorter than an original steering arm as well. In just in case you're wondering, the reason for that great big spacer on my steering arm is because when everything's up at ride height, I need that to make sure that my bump steer is as small as I can get it. And that, you know, has variation to do with a whole bunch of other factors. The big thing there with why it's so big is because the spindle is a 2-inch drop spindle, and we're trying to get the relationship between the lower ball joint pivot, the steering arm pivot out of the wheel versus the chassis side pivot and the steering arm pivot on the inside. So it's, I don't know, there's a lot of stuff that plays into this. Like, I've made some tools to be able to measure that, and then same thing, we're just trying to decide what to do here and try to simplify this. But you know, like I said, the boots are shot. They don't, as far as I know, they can't even buy this rack anymore. It's no longer on Holman's website. And really the only boots you can kind of get are for a Sweet Rack or a Mustang 2 rack, as far as what I was finding with any ease. And these Mustang 2 ones look like they'll work real well if I chop the end bellows, maybe 2 of them off. Should be able to get this snaked on there solid if I cut those ears off that I put on the rack. Otherwise, I'll have to end up kind of cutting a slit down the side, and then we're just getting a bunch of stuff back in there anyway. And at this point, I'm just leaning towards I'll just cut them off and try to make this work, because honestly, this thing's probably going to be transitioning to a little bit more of a street car in the future as I keep building on the tube chassis. So I'd rather have you know, everything stay a little bit cleaner in there. I don't know how well it'll fit with the round versus the square on the inside, but as long as we can get it close, we can try to pull it down with the zip ties or some wire or whatever. We'll figure something out. Alright, I removed those other bolt holes off the back. I bet just the pair of them was well over a pound. Of course, you know, I made sure that they were nice and heavy duty when I made them in the first place. I just cut the first step in the bellows off of the Mustang 2 boots, and I mean, it ain't perfect by any means, but hey, they're on there, and even with them having a bit of an opening on the end, it's probably still 500% better than it was before with the cut and then them just falling apart. So I don't know what to do about really sealing up the end, just because there's going to be a ton of movement back and forth. Everything's covered with grease, so I really can't silicone it, but I'm also not going to be worried about it. And once I put the bolt in, it's going to kind of hold it right there anyway. Might push around it a little bit, but everything will still function nicely. Also removed the stops that I had on there. I originally put these on to try to keep the tire off of the sway bar arm, but honestly, I think they, over time, they got pushed out anyway, and everything still rubs. So we're just gonna eliminate those altogether because they weren't doing their job anyway. Steering shaft is all hooked back up. Wheels are pointed straight-ish. Now that I moved those holes, I'm going to have to do an alignment again and check my bump steer most likely. But up top, I got that for play that's still left, which appears to be related to the servo drive because the U-joints and everything are moving with the slightest touch up here, but that servo wiggles around. And I don't know if that's something with just shimming it for tightness in there, or maybe it's just worn out, or maybe it's all still transferring from down in the pinion. I don't know. But I mean, the rack seemed like it was before putting the servo on, and clearly the column and all that stuff seems good. So the servo is kind of the last thing here, and I don't have another one laying around to check against or try. It also might just be in this connection here because it does have some wiggle in there, but as far as I know, that's totally normal because it's been like that the entire time I've had it. The real win here is that amount of play is probably half of what it was before in total amount, so I think we've definitely made progress in the right direction here. You know, it's just, I don't know, if you know something about that servo that I don't, and there's somehow play in that, or if it's because it moves up and down, like I figured some of that was just supposed to be for mismatch, and really the steering system should have a little bit of give in it. I mean, crying out loud, the old stuff had rag joints for stuff. You can't tell me that that didn't give one way or another a bit. But it didn't have this going on. And honestly, this driving down the road probably isn't going to be anything that I'm even going to notice. It's just I'm thinking about it from a performance standpoint where when I'm changing directions, like in a slalom, like it's just ever so tiny of a delay in the steering, and I was driving around the fact that it was quite a bit before, but I mean, hey, steering wheel is like pretty good. Like this is our from lock to lock in the tilt, up and down, side to side's practically nothing compared to what it was before. Yeah, that part inside the column must have been upside down and in there for a while, and I don't remember if I took it apart far enough for that before trying to do something and I screwed that up. I mean, if I did it like 3 years ago and just been dealing with it, but it's nice to have that fixed, and then the fact that it's not flopping around at the fireball now too. So a little bit of progress wherever we can get it.